In this topic, the operation of electromagnets is presented. Applications of electromagnets, such as solenoids, generators, and motors, are discussed. So we have just been looking at natural magnets and permanent magnets, but what about electromagnets? Well, we did briefly touch on this when we looked at the coil method for magnetization of a bar. In fact, passing a current through a coil of wire does produce a magnetic field similar to that of a bar magnet, including north and south poles at the ends. But how does it do this? Well, the basic idea is that even a single wire carrying current will produce a magnetic field around that wire. Now, in the case of a coil, the magnetic field produced by adjacent turns combines to form one magnetic field. The north and south polarities depend upon direction of current flow. If this is reversed, then the north and south poles will also reverse. But what can this electromagnet be used for? Well, clearly, if we can create a magnetic field by merely flicking a switch to pass current through a coil, then this field can be made to attract a soft iron plunger, which is mechanically connected to switches and other circuit devices. Here we have the basis of remote control. In another example, the coil can be wound around pole pieces of a DC motor or generator to create a magnetic field in which the armature rotates. This is the basis of electric motors and electric generators. Clearly, this subject of magnetism is opening the door to many concepts. One extremely important set of natural laws, discovered by a Mr. Faraday many years ago, provides the basis for all electromagnetic induction machines, including generators and motors. This diagram shows the three conditions which must exist in order to produce voltage by magnetism. First, there must be a conductor in which the voltage will be produced. Secondly, there must be a magnetic field. And thirdly, there must be relative motion between the field and the conductor. That is, the conductor must be moved by the mechanical prime mover so as to cut across the magnetic lines of force. When the conductor is moved so as to cut lines of force, a voltage is created in the conductor and current will flow if the two ends are connected together to complete the circuit. Now, if we move the conductor in the opposite direction, then the voltage is reversed and the consequent current will flow in the opposite direction. Similarly, if we were to reverse the magnetic field, the generation of voltage and current will be reversed once again. So that is the basis of electricity generation by rotating machines. But a slight variation on this can provide mechanical movement, so providing the basis of an electric motor. In this case, current is passed through the conductor, and the consequent reaction of the magnetic field causes mechanical movement of the conductor.